Hello, my name is Elise Steger, and I'm a geologist. In fact, I'm an environmental geologist. So what I do in my job is to take soil samples like this. This is a jar of sand, and I'll send it to the laboratory to make sure that there's no harmful chemicals in it. So it makes sure that people are safe around that soil. So whether it is if they're farming or if it's around construction, I want to make sure that the people that are handling that soil will be safe. So that's my job. But today we are going to learn about the rock cycle. And maybe you haven't heard about the rock cycle yet, but I'm going to be talking about a lot of terms that I know you guys have been learning today. So the rock cycle is how rocks are related to one another and how they can change from one rock to a different type. There's three types of rocks. I think you guys have learned this, that there is igneous, sedimentary, and metamorphic. So in the rock cycle, rocks or matter that is solid can be changed into a different type of rock. So the rock cycle starts with molten rock or magma that is underneath the Earth's surface. So the Earth has a core, a center, and then around that is the mantle or magma. And then the outside, the outer edge is the crust. And the crust is made up of large plates, like it's large kind of broken pieces. And I want you to go like this. And there's a couple things I want to show you with this. So pretend these are two plates and they're going to come together. That's how our Earth's crust is. And if you were to walk across, you wouldn't even notice this little piece in the middle, right? Now, but if you take your knuckles and kind of rub them against each other, you feel that little rumbling? So if the plates are rubbing against each other in this way, you might notice that rumbling. That would be an earthquake. So now you know, there's the plates. So now if the plates are pushing towards one another and they start to rise up, maybe they'll make a mountain. And this is called uplift. So I want you to go like this, rise it up. You just made a mountain. Now, there's also when the plates come in and they collide and they're pushing against each other and one starts to slide under the other. Subduction, right? So we have earthquakes rubbing this way. We might have uplift, or we might have subduction going underneath. Now, when subduction happens, the one side goes underneath and it gets a little hot down here towards that magma. And then that rock starts to boil, right? It starts to heat up and it becomes that magma. Now, the magma is what can generate igneous rocks. So if that magma starts to get warm and heated up and it kind of starts to rise a bit maybe, and it cools, it can form an igneous rock like granite. And since it's a slow cooling process, you can see it's kind of sparkly. Those are the crystals. That is how a granite rock is formed. Now, same thing, if that subduction happens and magma melts that rock and it comes up and it breaks through the surface, right? It'll come up to the surface of the crust like a volcano. And that, when it comes through that crust, the magma turns into lava. Now, lava, if it's super cooled, you can't really see the crystals compared to the granite rock. So this is our granite. This is basalt. You can't see the crystals. Now, you might find basalt in Duluth. If you've been to Duluth, a lot of those black rocks where you can't see the crystals is basalt. Now, a lot of us love the beaches and the harbor of Duluth. But if you look at the hill, it's that big hill in Duluth. Hopefully you've been there. If not, just imagine a big hill of rock. And that big hill of rock is called a rock formation. A large area of the same kind of rock is called a rock formation. Now, over time, rocks can break up. They can break up into smaller pieces. And it might be because of wind, might be blowing on it all the time and it breaks off little pieces. It can be due to water. and it can be due to ice, like a glacier sliding across it. And this is weathering. So weathering breaks down these rocks into smaller pieces. Now, we talked about water. If it's a nice gentle rain, just gentle rain come falling on the rock, it's not going to have much erosion. It will over time, but it'll take a long time. If it's a lot of rain, it has more energy, and that more energy will erode or weather that rock more quickly. Same thing with waves. Think of gentle waves kind of coming up against a rock. It's going to take a long time for that rock to erode. But if you have those crashing waves coming against that rock, there's more energy, and of course, it will weather more quickly. So think of that, has more energy. So rocks that have smooth edges versus kind of these angular edges, you can tell this rock has likely been weathered because it is smoothed out. So rock just kind of breaks into these smaller pieces, and it can break into such small pieces like this, guess what? Into sand, soils, that kind of thing. So it can break into pretty small pieces. Now, say we have a rock. This was a vesicular basalt because it has the holes. That's from the air when it cooled. So we have our rock here. I'm going to try to show you this. So here's our rock. And if it breaks into these smaller pieces, it's going to break into that little bits of sand, right? So imagine this, that if this sand breaks off of this rock and it moves away from the parent rock, if we go ahead and maybe have a little bit of wind, that is erosion. So we're moving that rock, those bits of rock away from where it originally was. That is erosion. You can do the same thing with water. I could pour water on this, and if the water moves that sand away from where it originally was, that is erosion. So weathering is in place. It just breaks away from the rock. Erosion moves away from that rock. So let's do a little recap. Let's look back at what we just learned. We have magma under the surface. If it comes up through, then it's lava, causing the rock underneath would be our igneous rock, which might be like granite. Lava rock on top would be like our basalt. Then if our basalt is on top, it can have our weathering. And if it moves away, then that is erosion. This little bit of sand here is called sediment. So when it moves away and it's deposited in another place, it is called sediment. Now, if we have a large amount of sediment, so if we were to pour a big thick layer of sand here, over time it gets really heavy and it pushes down on the earth, right? And so when we squish it down, it's called compaction. So when these layers get compacted, and then maybe a little liquid moves through the sand, that might cause some minerals to gel it together, to glue it together, that is when it becomes a sedimentary rock. So this is sandstone. You can tell there's little bits of iron here. So that's from the water that came through the sand and cemented. First it was compacted and then it was cemented together to cause sandstone. So one thing I want to talk about is not just sand layers or mineral layers. You can have plants that get piled up, squished down or compacted. And then that is a special kind of rock called coal. So you might want to look that one up. So if these rocks, these sedimentary rocks, are placed in an area where there's a lot of heat and pressure, that is what a metamorphic rock is. And a metamorphic rock, I'm going to show you one here. It's squished down, so there's layers. And sometimes it can be a little bit shiny because all of the minerals are in one direction. So this is called mica schist, and it is a metamorphic rock. So one thing I wanted to point out is that both metamorphic rocks and sedimentary rocks can also be eroded. So we showed how our igneous rocks and our both our igneous rocks, I guess, basalt and our granite can be eroded. But also, once these are deposited on the surface, guess what? Wind, water, ice, they can be subject to weathering and then erosion as well. So weathering, remember, it's just when they break off in place. Erosion when it's carried away to a different place. So guess what? These can also pretend that this is our plate, can be subducted again and turned into a new rock. So that is the rock cycle. I hope you guys learned something and have a great day.